Hi everyone, I hope you're all doing well and trying to make the best of the situation. I wanted to take a look at this homework assignment and maybe go through a few problems with you guys, a few different problems. Here in question number 1, remember this is pronounced log base 36 of 6, and that just means 36 to what power is equal to 6, and we know that 36 to the 1/2 power is equal to 6. It's kind of like just taking the square root of 36. In problem number 2, if there's no number down here, then that just is implied to be a 10. So we know that 10 to the 3rd power is equal to 1,000, right here. If you ever see a number right here of 1, this question is read as 8 to what power is equal to 1, and we know that if we raise any number to the 0 power, then that is 1. In question number 4, we have the natural log of e, and the natural log of e are inverses of each other, so we're left with 5 as our answer. In question number 5, we have 5 to the log base 5, and those are inverses of each other, so they cancel each other out, and we're left with just 13. Keep those properties in mind for question number 5 and number 4, because those will help simplify a bunch of problems. In number 6, this is saying 2 to what power is equal to 1/4, and what you want to do is try and make these bases the same on here. Well, I know I can write 1/4 as 1/2 to the 2nd power, and then 1/2 to the 2nd power is the same thing as 2 to the -2 power. So if what I originally started out with was 2 to the x power equals 2 to the -2 power. If the bases are the same, you can set their exponents equal to each other. So x is equal to -2. Sorry for that over there. All right, let's talk a little bit about expanding and condensing using these log properties. We have log base 5 of 7 times x over 2y to the 3rd power. Remember, if you ever see multiplication, that means addition using the properties of logarithm. So it's log base 5 of 7 plus log base 5 of x. And then whenever you see division, well, that's a subtraction according to the properties. So minus log base 5 of 2 minus 3 log base 5 of y. And the 3 comes from the power property. If I had something that, let's say it was log base or log of y to the 5th power, this power would come out in front of the log. So we would have that there. And then the same thing works backwards. This 2 out in front becomes the power on the y. And do you see an addition sign there? So that's why these are multiplying each other. And then there's one subtraction sign there, so that goes in the denominator. And then you always want to simplify as much as you can. So that's where that 4 came from right here. We talked about these problems 11 through 14 last week, Thursday and Friday before we were off. So keep those shifts and those reflections and those things in mind based on what we learned in chapter 1. And then these you guys should be somewhat familiar with based on what we did in Algebra 2 using the PERT formula. If they say it's compounded continuously, go away. If it says it's compounded continuously, you're going to use this formula right here. And then if it's compounded quarterly, monthly, yearly, that's when you're going to use this formula right here. So in problem number 15, they say it's compounded monthly, so we're going to use this formula right here. Keep in mind, the rate has to be in a decimal version, not as a percent. So 4.75% is the same thing as 0.0475%. And then keep your order of operations in mind when you do these types of problems. Let's talk about the last thing, which is the graph of an exponential and a logarithmic function. So we studied these before we left, and this is an exponential graph, and this +1 right here shifts the graph up 1. So the original graph would have an asymptote here at y equals 0, and it would go through the point 0, 1. Here's what the original graph would look like. And that could be y equals, say, 4 to the x power. That would look like this right here. This +1 just shifts the graph up 1. So if it shifts it shifts exactly this graph up 1. So it's going to move this asymptote from y equals 0 to y equals 1. And now this point right here becomes 0, 2. The natural log of the graph, or a logarithmic graph, is the inverse of an exponential graph. So we know in the notes we learned that the x and the y values switch, the domain and the range switch, and their inverses, their reflections of each other in the line y equals x. So here's what a typical logarithmic graph looks like, or I would say a generic logarithmic or natural log graph. It has an asymptote at x equals 0, and instead of going through 0, 1, it goes through 1, 0. So here's, like I said, what the parent function would look like. Well, what happens here, do you see this +2 inside the parentheses? That's going to shift your graph to the left 2. So if I took this point right here and I shifted it to the left 2, it's now going to end up at -1, 0. And here's the asymptote at x equals 0. Well, I'm shifting it to the left 2. That's going to end up at x equals -2 on there. So keep in mind all of these properties right here. We've done these before in chapter 1. You guys are pretty good with those things. And then I think the last thing I want to talk about with you guys is how would you do this stuff without a calculator? So you want to use all the properties that we learned. We're going to use the power property here. We're going to take this and raise that there. So that's what I did right here. And remember, raising something to the 1/2 power is the same thing as taking the square root of that number. So the square root of 144 becomes 12. Can't really do anything with this right here, so I'm just going to bring it down. Now that these two have the same base, log base 3, I can combine these using the properties of logarithms. Since that says subtraction, I'm going to divide log base 3 of 12 divided by 4. And log base 3 of 12 divided by 4, well, now I can simplify these. 12 divided by 4 is 3. And log base 3 of 3, well, this base is the same as that number. They cancel each other out, and you're left with 1 on there. And one last problem. Log base 4 of 14 minus log base 4 of 21 plus log base 4 of 3. I can't really simplify anything right now, but I do notice that they all have log base 4s. So I'm going to rewrite this. I'm going to condense it as 14 times 3 all divided by 21. It doesn't matter that this is in the middle. It can be here, or it could even be here. If you ever see a negative in front of it, that just means it needs to go in the denominator. So that 21 is going in the denominator. And because there's a plus here, that means the 14 is going to multiply 3. So 14 times 3 is 42. 42 divided by 21 is 2. And now we have this right here, log base 4 of 2, which is saying 4 to what number is 2? And that number is 1/2. All right, guys, stay healthy. Send me an email if you have any